In the previous video, we were looking at visual analysis on a categorical column. In this video, we will look at visual analysis on numerical columns. We can pick one numerical column at a time and try to do the following. First, we can see what is the distribution of these values using histogram, and we will see the different quartiles in the numerical column using box plots. And we also understand, are there any outliers in our numerical column either using box plot or also using histograms. Let us understand them one by one. Let us start with histogram. Let us take up a example. Assume we have a age column, and let us say we have a customer and we have a age column. So, customer A is having around 30 age, customer B is around 40, C around 50, like that. So, when we pass the age column alone to histogram, we will be getting a output something similar to this. So, here the x axis is for age, in the y axis we have the frequency. So, here the first bar represents a bin which is ranges between 0 and let us say 10, and the second bar represents a bin which is ranges between 10 to 20. So, like that we have 20 to 30, 40, 50, 60, 70, etc. So, for every bin that we see here, we have the corresponding frequency. Let us take here total number of customers between 0 to 10 could be around 50, and let us say number of customers who are between 10 to 20 could be around 100. Likewise, for every bin we have the corresponding frequencies as well. These bins usually by softwares will be picked automatically. The interval will be same. So, for this bin the interval is 10, and for this bin also the interval is 10, and this bin as well the interval is 10. In actual histograms the width will be exactly same. So, here it just slightly differs, but in actual histogram we will have the exact bin ranges and the bar widths will be same for each of these bins. So, let us understand why we need a histogram and what we can interpret from it. One of the main reasons to draw histograms is to identify the distributions of the numerical column. So, we have ranges here 30 to 40, 50 to 60, 60 to 70, like that. If you try to draw a virtual line which connects all these midpoints of the bins, you might get a graph like this. So, if I have to draw this line alone in a separate chart, we might get a distribution which is something similar to this. So, this is a symmetrical distribution where we have the mean and median which are almost same. So, here mean will be approximately equal to the median. There are chances that we could get distributions where it is not symmetrical, but most of the values are towards the right hand side. So, if we try to draw a density function, which is ideally you should not do, but for just for the understanding, if you try to draw a ideal distribution line, it might come something like this. Where the the distribution is slightly shifted, and this kind of distributions are called skewed distribution. Here the mean is lesser than the median, because the distribution is slightly shifted and we have a very long tail towards the left hand side. Hence, this can be called as left skewed distribution. On the other hand, there could be some other distributions which might look like this, where most of the values are towards the left and we have a very long right tail. The distribution might look something like this. So, here the median will be less than the mean. So, these kind of distributions are called right skewed distribution, because we have a very long tails towards the right hand side. And there could be situations like where you might have distributions something similar to this, and it might have multiple peaks and all. So, depending upon the distribution, we can try to match it with some standard distributions like Gaussian, uniform distribution, bimodal distribution, multimodal distribution. Knowing the distribution of a particular numerical column will help us to understand the characteristics, and also it will help us while we are doing some machine learning algorithms, because certain machine learning algorithms assume certain distributions on the input variables. We can check whether these assumptions are validated in our data or not. Now, I guess you have a little bit understanding about what is histogram and how to understand the distributions. One other main reason to look at the histograms is to identify are there any outliers. Chances are there that if you have a distribution something like this, for our age example, most of the values might range between 0 to 60, and you might have a very small number of values with age between 90 to 100, and it is clearly evident that this is a outlier in our data, maybe due to data error or the characteristics of the data or the employees or the customers itself like that. Irrespective of that, this particular section is an outlier. Any values within 90 to 100 can be treated as outliers, and if you want you can perform some outlier treatments as well. So, using histogram we can perform distribution analysis and identify whether it is left skewed, right skewed or symmetrical distribution, and we can also check are there any outliers. Now, you should have a fair bit understanding about histograms. Let us see how to implement histograms using R. Now, let us try to understand how to create histograms using R. So, we have a very simple function called hist, to which we just have to pass the column in which we have numerical values. For example, in our case we have age of individual employees in our HR data. Let us try running this. By default, R will pick up its own number of bins, and there are certain algorithms behind that. So, here if you can see, the bins are like between 20 to 25 and 25 to 30, 35 to 40 and 45 to 50 like this. So, the bin width here is 5, and for every bin we have the corresponding frequency as well. So, to interpret this, we have around 100 employees who are within age 20 to 25, and most of the employees are between 30 to 35, followed by 35 to 40. To this distribution, if you try to plot a density curve, so this looks like close to symmetrical distribution. The mean and median might be approximately same. If you want to increase or decrease the number of bins that is selected by default, you can use breaks parameter. So, you can specify how many bins you want. For example, here if I specify that we want 15 bins, so the number of bins is now increased. So, between 20 to 30 itself we have lot of bins. Earlier we just had 2 bins between 20 to 30, now we have close to 4 or 5 bins in between 20 to 30. Likewise, you can try decreasing it as well. And remember, the interpretation might change depending upon number of bins that you are selecting. So, you have to be very careful while choosing this, and there are a lot of guidelines under data analysis in picking the right number of bins. And I guess it is best to leave it to the default, so that R understands the numerical column that we are passing and chooses a optimized number of bins for this particular numerical column called age. So, you can try the same for other numerical columns also. For example, we have a monthly income, where the distribution is not symmetrical. Most of the values are towards left hand side, and you have a long tail on the right hand side. So, this is a right skewed distribution. And let us pick one more numerical column, which is monthly rate, whereas here this distribution looks completely different. The frequency of all these bins are almost same. Maybe we can call this as a uniform distribution as well. So, it is ideal to look at the distribution of individual numerical columns and understand the underlying distribution, which might help us to further characterize our data. In this video, we are going to learn what is box plot, how to interpret them, and how to visualize them in R. In order to understand what is a box plot, we need to learn few terminologies like 5-point summary, percentile, quartiles, etc. Let us understand them one by one. First, let us start with 5-point summary. It is best explained with an example. In R, we have a function called quantile, to which if we provide a numerical column, it will result 5 numbers to us, and these are the percentiles numbers. Percentile is a measure used in statistics indicating the value below which a given percentage of observation falls. For example, 50th percentile tells us what is the number below which 50% of the values lies. In our example, it says 50% of the employees are getting below 4,919 and 25% of employees gets below 2,911. Likewise, we have few default percentiles which are displayed in R using quantile function, which are 0 percentile, 25th percentile, 50th percentile, 75th percentile and 100th percentile. And these percentiles have special names. For example, 0 percentile will usually represent the minimum value, and 100 percentile will usually represent the maximum value, whereas 25th percentile has a special name called first quartile. and 50th percentile has a special name called second quartile and also can be called as median in our data, whereas 75th percentile can be called as the third quartile. So, percentiles will help us to understand the value below which a given percentage of observation falls, and for percentiles like 25th percentile, 50th percentile and 75th percentile we have special names like quartile 1, quartile 2 and quartile 3. In R, to create a box plot, we can use box plot command and pass the numerical variable that we are going to use, which is monthly income. Box plots are graphical representation of 5-point summary. Let us understand this chart in detail. We have multiple lines in this particular box plot. Let us start from the bottom. The bottom line is called lower whisker and the top line is called upper whisker. The line below the box is called quartile 1 and the center line is called quartile 2, which is also the median, and the line on top of the box is quartile 3. The dots that you see on top of upper whisker are nothing but outliers. Later on we will see how to calculate the outliers. The difference between quartile 3 and quartile 1 is called interquartile range, is nothing but IQR. So, IQR is nothing but Q3 minus Q1. This number will give us an idea about in which range does 50% of numbers are populated. In our example, it gives an idea about in which salary range that 50% of employees are lying, which also includes the median salary. In many of the statistical software including R, IQR is used to calculate the outliers in the numerical variable. You can search for box plot in Wikipedia and understand different formulas exist. Let us take up the example that is plotted here. So, the value of lower whisker can be calculated using the formula Q1 minus 1.5 times the IQR. Any value which fall below this can be treated as an outlier. Likewise, for the upper whisker we can calculate it using the formula Q3 plus 1.5 times IQR. Any value which falls above this is outlier. Likewise, any value which falls below the lower whisker is also an outlier. In this particular example, at least we do not have any outliers below the lower whisker, but we have many outliers above upper whisker, and we can exactly calculate what is the value of upper whisker using the formula Q3 plus 1.5 times the IQR. So, box plot will help us to understand the quartiles, and it will also help us to understand the outliers that are available in our data. We will be looking at in detail about how to further interpret box plots when we are learning bivariate analysis. We will be taking up a similar box plots, but we will plot multiple box plots next to each other so that we get more value out of those. As of now, what you need to know is how to create a box plot and how to get the values for the outliers and understand the IQR. That's it.